Good morning, everyone. This is Prajwala from Sri Venkateswara College of Engineering. Today, we are going to discuss about clipping. What is clipping? Generally, any procedure that identifies those portions of a picture that are either inside or outside of a specific region of a space is referred as a clipping algorithm or simply clipping. Polygon clipping, Sutherland Hodgman algorithm. A polygon can also be clipped by specifying the clipping window. Sutherland Hodgman polygon clipping algorithm is used for polygon clipping. In this algorithm, all the vertices of a polygon are clipped against each edge of the clipping window. First, the polygon is clipped against the left edge of the polygon window to get new vertices of the polygon. These new vertices are used to clip the window against the right edge, top edge, bottom edge of the clipping window as shown in the following figure. While processing an edge of a polygon with clipping window, an interesting point is found. If edge is not completely inside clipping window and the partial edge from the intersection point to the outside edge is clipped, the following figure shows left, right, bottom edge clipping algorithms. Clipping left edge. Here, the polygon on the left side is clipped inside the clipping window. In the next figure, the polygon is the right side, which is outside the clipping window, has been clipped inside the clipping window. The polygon, the figure in the bottom refers clipping top edge. The polygon of which is outside the clipping window has been clipped inside the clipping window. At last, the bottom polygon, which is outside the clipping window, has been clipped inside the clipping window. Let us understand this clipping method. To clip a polygon, we cannot directly apply a line clipping method to the individual polygon edges because this approach would produce a series of unconnected line segments. The clipping polygon must be a bounded area after clipping as shown in the figure. It shouldn't be a disconnected polygon after it has been clipped as shown in the figure. For polygon clipping, we require an algorithm that will generate one or more closed areas that are then scanned converted for the area fill. The output of a polygon clipper should be a sequence of vertices that defines the clipped polygon boundaries. Steps to solve a polygon clipping. Clip a polygon by processing the polygon boundary against each window edge. Apply 4 cases to process all polygon edges to produce sequence of vertices. This sequence of vertices will make a bounded area. Beginning with the initial set of polygon vertices, we could first clip the polygon against the left rectangle boundary to produce a new sequence of vertices. The new set of vertices would be successively passed to a right boundary clipper, a bottom boundary clipper, and a top boundary clipper. Steps of Sutherland Hodgman polygon clipping algorithm. Polygons can be clipped against each edge of the window, one at a time. Vertices which are kept after clipping against one window edge are saved for clipping against the remaining edges. Note that the number of vertices usually changes and will often increases. First, the polygon's left side has been clipped inside the clipping window, and then we clip the right side of the polygon into the clipping window. At each step, a new sequence of output vertices is generated and passed to the next window boundary clipper. Here we can see that the left clipped polygon has been saved while it is being clipped to the right clipper. 4 categories of polygon clipping. There are 4 possible cases when processing vertices in sequence around the perimeter of a polygon. As each pair of adjacent polygon vertices is passed to a next window boundary clipper, we make the following testers. 4 possible scenarios at each clipper. Each edge goes through 4 clippers. The rule for each edge for each clipper is if first input vertex is outside and the second is inside, output the intersection and the second vertex. If first input vertex are inside, then just output second vertex. If first input vertex is inside and second is outside, output is the intersection. If both vertices are outside, output is nothing. Here we can see that V1 is outside, V2 is inside, and V1 dash is the intersection between them. Inside to outside, inside to inside. Here both V1 and V2 are inside. So the output is V2. The second vertex is considered as output. Here V1 is inside and V2 is outside. And we consider V1 dash, which is the intersection between the V1 and V2. If both the vertices V1 and V2 are outside, we consider the output as nothing. The first vertex is outside the window boundary and the second vertex is inside. Then both the intersection point of the polygon edge with the window boundary and the second vertex are added to the output vertex list. Here V1 is inside and V1 is outside, V2 is inside. We consider V1 dash as the output. If both input vertices are inside the boundary, inside the window boundary, then only the second vertex is added to the output vertex list. If both V1 and V2 are inside, then we consider V2 as the output. If the first vertex is inside the window boundary and the second vertex is outside, then only the edge intersection with the window boundary is added to the output vertex list. If V1 is inside and V2 is outside, V1 dash is considered as the output. If both input vertices are outside the window boundary, then nothing is added to the output vertex list. Thank you.